So we're going to be taking a look in our next hour or so here. We're going to be taking a look at containers and apps up on GCP, as well as the deployment of the monitoring tools that are available to us to actually go and do all this stuff up on GCP. So first off, we're going to talk about containers in the cloud. Now, containers. How many of you are working with containers already? Anybody working? Docker containers? Yep, microservice design, that sort of thing. So I'm going to give you a little bit of a background behind containers here, and then we'll talk about Kubernetes and then some of the other options on running resources up on Google. Now, most of your organizations are probably at least talking about containerization at this point. And containerization on Google can happen in several different places. One, you could actually run containers on Compute Engine. You could take a generic Ubuntu or CentOS or Red Hat or any of the VMs and load up Docker and run a Docker container. You can actually, there are a couple VMs pre-built ready to run Docker containers, the container optimized systems. But you can also go to the other end and say, you know what, I have a Docker container, I've already built it, and it's a single container, it does everything I need to do, it's all self-contained, I'd like you to deploy that on App Engine. And so Google, and they could take over the management. But then there's the middle ground. There's the piece in the middle saying, I have complex containers. Okay, I've got containers handling part of my front end of my application. I've got containers handling the middle and the back end. So to give you a visual to think about with that, let's think about a banking type application. We all go up online and visit our bank or our credit card or things like that. So they've got a front end web server. And then we've got a bunch of, there's obviously some sort of back end databases. But what sits in that middle? Well, traditionally, it might have been a big monolithic application that had all that code in there that web server talked to. But more and more, we started to break that up. We broke that into a lot of smaller components to put together. So like maybe there's a small component that has all the functions to go get bank account balances. Okay, so let's call that our get bank info. So we might have that running in a container and the code just to go back. So we pass it a request to say, here's the account number, go back and come back with the value. Or here's the account number, go back and come back with all the transactions between the date range we provided. And instead of that being in one big application, we put that in a little small one. And then maybe you have another one to transfer. So maybe I've got transfers where it gets passed a parameter saying go from this bank account to this account, this amount. And that would be in another, that's not in that big monolithic application that whenever you change something, you have to change, you have to recompile that whole big thing, you just work on that little piece. And so when we talk about complex container orchestration, we're talking about a lot of these smaller pieces in the middle that we need to build. And so those actually, I don't want to run those individually on VMs. I don't want to have to manage that beyond just a single VM. But it's also, it's not just one, which is where I'd often deploy with App Engine. So we use Kubernetes for that. Now, Google created Kubernetes internally because they went through the microservice architecture years ago to build things out. And many of us are still making that journey that direction. But as we get more and more mature in our container creation, we're going to wind up with a lot of little containers that all need to be loosely coupled together. And we'd like to have load balancers and all that sort of stuff with them. And so that's where Kubernetes fits in. So less about the servers, although there's still servers there in Kubernetes, whereas App Engine is more about the full managed. But we've got to conform to the specific requirements of App Engine where we do things. Or a simple container architecture leads us to App Engine. Complex containers lead us to Kubernetes. That's kind of where you choose where do these things go. Okay, so let's talk about containers just a little bit. Now, for years, we've used virtual machines. Who's run a virtual machine before, a VM? Yeah. Who's run a server? So we buy a server. It's got 256 gigs of RAM. It's got a bunch of hard drives and stuff. We load up a hypervisor like VMware, Hyper-V, something like that. And then we build 5 or 10 VMs. What do we now have to manage? 5 or 10 operating systems, because every VM has a complete instance of the operating system and everything else. Now, also, every VM platform has a different configuration. This is where I would love to get in a technology time machine, go back like 15 years and get all the various virtualization players in the same room and say, guys, you don't get to leave until you come out with a standard platform for what a VM should look like. So a standard configuration file in a standard disk format. And how would our lives been for the last 15 years if we did that? Our lives would have been a lot easier, wouldn't you say? Yeah. Well, we can't fix that. So we're stuck with all these different virtual machines. Now, Google makes it fairly easy to take an on-premise VM and actually migrate it up into Google. Okay, you actually see it right there in the console. They've got Migrate VM tool. So Google bought a company, I think Velastrata. Google bought that to help with companies to take and move their on-premise VMs up into GCP. And you'll see that right in the console. So you can lift and shift the VM up in there. And they're always coming out with more and more tools. In fact, there's even some tools in the works right now, if you've been watching the news and stuff, about taking VMware VMs and bringing them right up to Google and running them. But what's the next generation look like? So a lot of us are still in that VM generation. How does this map to what containers are doing? Well, with a virtual machine, we virtualize the hardware, but we still had to have separate operating systems. Well, what's different and what's the same between Ubuntu, CentOS, Red Hat, Debian, all the different Linux flavors? What's different about them? They're tools. What's the same? They're all running a bare Linux kernel at the bottom. It's the same Linux kernel. So what if we put the Linux kernel into the hypervisor? Okay? So you don't have a different instance of the operating system inside each virtual machine. The hypervisor has the kernel in it. And then we just need what's different about CentOS versus Ubuntu versus whatever. We just need that small little piece above it. And that's what's happening with containerization. So we move up the stack. So if we look at this diagram, we start with the hardware, we then have the hypervisor, then we had to have each VM have the OS. But what happens when we move it up? What happens when we get rid of that and we say, wait, they all have the same OS if they're Linux, and we just need what's on top? So we start to basically move up the stack. So, back here, this is where, on the left is the traditional separate OSs. The idea is, can we get something like the right, but could I actually merge the whole OS together? So the same OS is being used by all, or just the piece that they all share in common. So, over on Google, there's a couple ways to handle this. As I said, you could do Compute Engine, and we could go to the other extreme and we could run on App Engine. So App Engine provides you the ability for you to basically deploy your application on top of Google Cloud Platform and not worry about the servers. Okay, so we could go ahead and put our containers up there. So maybe we have a container for billing, for orders, for inventory, and services and all that. And we start to put this all together. As our demand increases, based on the component to our application, the components can scale independently. So think about my banking example. The accounts, well, they're always looking at their accounts, but what about transfers? Maybe there's a lot going on in the evenings for consumers. What if we had stock trading going on as well? So we had a little microservice, let me trade stocks. Well, that only needed during the day. Everything done at night. So those can all scale down. So things can scale up and things can scale down and all that sort of stuff. And you want to have it sitting on the platform so that you can go and talk to your data and storage and all that other sort of stuff. So basically, the container gives us the idea that we get flexibility because all we really need is the OS and the hardware is all down in the lower levels. And our application is really just the libraries we need plus the applications we need. So it abstracts the OS now. So if you want to think, virtual machines were what we did 15 years ago when we spent the last 15 years moving everything to VMs. We're now trying to optimize that, and we're moving one layer higher up in the stack. Okay, faster startup, because the OS is already initialized. I just need to load the libraries that I need for my application to run. And we're good from there. They're built to be configurable, self-contained, and ultra-portable. They are the sort of idea that I could build a container on premise and then run it up in the cloud. So I could build it on premise, Docker on my Linux development or my Mac. I then bring it up and I drop it onto a container execution environment, whether that be App Engine or whether that be Kubernetes or whether that be a compute engine with Docker loaded in it. I can go and run that up on GCP or any other cloud. And that's the key. I can be cloud agnostic. Now, a lot of our executives go to meetings And they come back and say, your company should be cloud agnostic. You should wake up each morning and find out who's the cheapest cloud and deploy your application there. Anybody heard that? Yeah, and then we say, you're crazy. That's like saying, yeah, we can use every brand of laptop, but we're going to settle on one mainstream one so that we can take advantage of economies of scale and stuff like that. But it's a good idea. So the idea, though, containers is the one thing that would get us there. Because the idea is once I build a container, it's only dependent on there being a Linux kernel as part of the hypervisor. And so that's where we start to go. So I want you to think, if somebody says, containerization, for those of you brand new to it, just say, it's a VM without the operating system in it. The operating system is being provided by down below. Now, what we often do is we go ahead and we configure the host and say, I want you to run this container. And remember, we're not building big, gigantic applications as containers. We're building small little components that are all loosely coupled together so they can communicate with each other. So we can run lots of them, and we can scale them each independently based on what we need. We connect them via networking, but that networking all happens within the container software when we're running on a single machine. And when we're running on multiple machines, well, they're all combined together via the cluster. So the Kubernetes cluster is a cluster of compute engine instances running the Kubernetes software and then managing the execution and the scaling up and down of all those containers, the load balancers, and all that other fun stuff. So when we go and take a look, Kubernetes really makes it easy for us to go and orchestrate many containers running on many hosts. So I'm going to kind of describe something here. So imagine we all use, how many Google apps did you use this morning? How many? At least 3? Yep, so what? We probably use Maps to get here. Gmail, maybe to look at your personal email. Maybe, what was your third one? Google Drive, look up a document, find out your registration information, all that. Yeah, maybe watch a YouTube video before, on the train or the bus, or while you were driving, not while you were driving. All right. Now, so all of this. Well, obviously, throughout the course of the day, what you're doing on Google varies, and where Google needs to shift their capacity. So in their data centers for the own operations, they don't have a dedicated set of servers for Maps, and another dedicated servers for Gmail, and a dedicated servers for G Suite for business email, and a dedicated for Google Drive. What do? They've got containers everywhere. And literally what happens, it's like, all right, everybody's headed to work, so we need more maps. So more containers running the map, more instances of that coming. And then it's like, okay, everybody's checking their Gmail. But now they get to work. So we need less maps, and now we need lots of G Suite containers running. And then the afternoon comes along, 3 o'clock. Whoop, we need some more YouTube. People start getting bored at work. Whoop, Maps is starting to come on. Whoop, the kids are out of school, need more Pokemon Go containers. Things scale up and down. What do I look like up here? I say, hey, give me more tuba. Flutes, calm it down over there. And give me more, more bras, right? What do I look like? A conductor. And what am I conducting? An orchestra. That's why we call this sort of stuff. When we start to do this, we're orchestrating all of these containers running. Now, Google mastered this with Kubernetes, although they're always still evolving, but this is how they made these billion user applications, by orchestrating all those applications running so we can scale up and we can scale down. Okay? So that's what's kind of going on here with it. And so they're good at, so if you just have one container, you can say, Google, I hear you're really good at container orchestration. Here's my container. It's pretty monolithic. I've got pretty much everything in there. But as you start to evolve in your design and your architecture and things, you start to break those into a lot of pieces. You start to understand containers more, and you start to say, hey, I'm ready to do more. So if you were to Google Snapchat, Snapchat started on App Engine at Google, where Snapchat just gave Google their code. And basically it ran. They didn't have people running servers and operations and things, but as they've matured, they become more and more in building a lot of microservices and starting to manage those more. And so now they start to do the Kubernetes, but they didn't go back and buy servers and install Kubernetes and all that. They said, well, Google's already got Kubernetes, so I can ignore that whole server part. Sorry, hardware guys. Sorry, server admins and all that. They don't need you. Yeah, we better learn new stuff. We better learn how to build VMs and the stuff up above. We better learn how to manage our Kubernetes clusters, things like that. And then so we deploy on Kubernetes instead. And so Google managed that Kubernetes cluster. I say, here, deploy my application. All right, so where does it all start? It starts by building a container. So to give you an example, here's a simple Flask application that's going to run on a web server. So this is code. This is app.py. We're importing Flask. So this is just regular Python code to run a little server. We create our file. We go ahead and put it in a directory. So this is just a simple little hello world. We might provide a requirements file. So we tell basically the container, what do you need to run? And it says we need Flask 1.2, and we need UWSGI 2.0.15. And then we create a Docker file. And this is the instruction that tells Docker how to go about it. Okay, so it says, okay, start using Docker. So the first line that's not even there, imagine, there's one that says, start with a Linux kernel. That's what Docker provides. Remember, that's part of Docker. That's part of Kubernetes. That's part of the underlying. They assume the OS is already there. Now, what was the difference between Ubuntu and CentOS and Debian and all those? The pieces sitting on top of the Linux kernel. So in this particular Docker file, we've said from Ubuntu 18.10. So we go out to Docker, because this doesn't have anything else. So Docker just kind of assumes, okay, this is up in Docker Hub. They have all of the pieces that are the difference between a generic Linux kernel and Ubuntu, and it's like 200 megabytes. Okay? So it goes ahead and adds that. Now there are others. We could have seen from Alpine up there, Alpine latest. Alpine's like 5 megabytes. It's what's the difference between a Linux kernel and basic tools to run on something. So some people, anybody use Alpine as their base for some of their containers? Yeah, a couple people raising their hands, cool. So, but this has got Ubuntu. So literally, after that first component run would basically start with a Linux kernel at Ubuntu. And then we want to do an apt-get update. So update that base that we got, and it was running an update, and it's installing Python 3 and Python 3 development. So we're saying add these. So take, it's like a script. Okay, it's like a script saying start with a Linux kernel, add this, do an update, add Python 3 and Python 3 dev, copy the requirements file into a directory called app requirements, txt, go change to the application directory, so like that's like doing a CD, and in there now I want you to run pip, and I want you to install all the references in the requirements file. So we need Flask and we need UWSGI. So it goes ahead and installs those into the container. Then it says, okay, copy what's in the current directory. So copy the current into app. So we've gone ahead and said, well, there's our actual code. And that actually should be entry point, not endpoint. But entry point to saying, I want to run Python 3, and I want you to run app.py. So app.py was this file. So all that basically says is start with an Ubuntu machine, or what's on top of Linux, start with Ubuntu. Go ahead and update Ubuntu and put a couple things I need in there. Put Python in there so it can run Python. Don't worry about putting anything else. There's only the bare bones in here. And then these are the additional requirements, so install these because my code needs these. And then say when this container runs, go ahead and make the application run Python app.py, which will create a web server that's listening on the machine. And presto, we've deployed a container. Now, what do I do with that? Well, once I have the container, I build it. If I'm playing with this on my local machine, my Linux machine, my Mac, in Windows, I can do this. I just need Hyper-V because it builds a little Linux machine because I need that Linux kernel, and that's not inside Windows. But we basically need a little Linux environment. So the kernel is there, and so we're doing our development over here, but the Linux kernel is still at the heart, and it's part Docker's leveraging that. And so we say, Docker, build -t py server. So the name of my container is going to be called py server, and I want you to use the current directory in, and that current directory has the requirements and the Docker file and the app.py in it. And with those 3 files, Docker can build it, and then we can run it to start the container engine. So we start the container off. So we build locally. And that's the key. Remember, we want to build locally. I don't want to have to necessarily be on the cloud to do my development. I want to do that on my development machine. I want to containerize my application that I built and then create a container. Now, I can tell the system to run. That Docker run says run it locally. If I do that and it's not local, it might look up to Docker to see if there's an image out there. So for example, if you were to go home and type and you had Docker load, you said Docker run Minecraft, you could actually probably find a Minecraft server up there on Docker that's ready to go. Or you want to say, I want to run, yeah, the Minecraft's just kind of a cool example, you know, out there. If you got kids who you want to kind of freak out in Minecraft, build a Minecraft server, they're playing, and then you jump in and start chasing after them, and they freak out, especially 6-year-olds. I got one of those. So. But there are Docker containers for everything. Another more exciting one, a graph database. Anybody work with Neo4j? You could go out there and you could do Docker run, a couple extra parameters in there, and you could run a graph database from Neo4j. You know, so you can go experiment. You can run a MySQL, there's Postgres, there's tons of implementations of things to build. Or you could take your own container that we just built and put that into a registry. Google, within the project, has GCR, Google Container Registry. I'm actually going to show you that at the end of this section. I've got a full CI pipeline going where I've got a little small application. I'm going to change it, and then I'm going to check it in as code. And then Google is going to take it from the source, so like a mini Git sitting in my project. It's then going to compile it up using Google Cloud Build, and it's going to put it into the container registry. And we'll go from there. So all of this, so this whole container idea, we're going through a massive amount of, it is re-platforming of an application to take it from something that might have been standalone or a monolithic application, break it out apart and rebuild it. But the benefit to it allows it to scale independently, allows a lot easier development without everybody checking in and out and working with one common large scale application that takes hours to build. Instead, we change the containers. So the Kubernetes API then gives us, once I have a container, a platform to actually go and run it. Okay? The nodes for container, for Google Kubernetes engine, are actually compute engines. So you decide from Google, you say, hey Google, I want to build a new Kubernetes cluster. I want you to use N1 standard 4. So I'd like each of my Kubernetes node to be 4 CPUs with the standard allocation of RAM. And they'll fire up 3 of those in a zone. Or I can say, hey Google, I'd like to be multi-zonal. I would like you to spin up a Kubernetes set of Kubernetes nodes in 3 different zones within my region. So now I could have 9 nodes there ready to run my containers. And then I describe how I want my containers to operate. Now, it's very declarative. One of the big changes we had is in virtual machines, we often describe them as their imperative operations. We boot up a VM, we log into a VM, and we do something. Whereas containers are much more declarative. We declare what we want it to do, and then we say, go do it. And now, so my application can talk to it, but I don't go into containers very often and actually tinker or tell it to do something. I go back to the source and I build a new container if I need a change. So we basically change the code, we change the Docker file if we need to, and we redeploy that container. And then we upgrade the containers that are in production. So the Kubernetes API lets me do things like, all right, I want gcloud, container, cluster, create. And just like we did gcloud, compute, instances, create, and the VM name, this is going to do the same thing. This is going to spin up, though, an entire Kubernetes cluster. Now, I can do it through the graphical interface, but more and more as an organization, as we mature in a lot of these technologies, we start to think more of infrastructure as code. Everything I do should be able to be called as code. So in my development environment, I might say, okay, we're going to do gcloud cluster create, the name of it, and build sort of a whole little, if it's your shell scripter or a batch file creator, build all the commands to go and build that up. Or if I'm a developer, I might do all that with API calls. Or if I'm an infrastructure person, I might move to a platform, I might use a platform like Google's Deployment Manager or Terraform, which is an open source platform for building infrastructure as code. So the idea is I declare what I need it to be. So in development, I've built sort of, this is my build and I've got it all. So then I go and say, okay, in my test or my QA environment, let's see what happens when I run this script, or I run this deployment with Terraform, or I run my infrastructure as code. And does it work? Oop, didn't work. Let me go back, let me make some adjustments, let me test it again. And when I'm ready, I use that to deploy my production. Oh, anybody ever have to stick around on a weekend to do like a disaster recovery test or drills or anything else like that? Now, if we have infrastructure as code and we're deploying containers and all this, guess what we do? One Thursday afternoon at 2 p.m. in the afternoon, we say, you know what, disaster recovery drill time. Boom. What do? We go run the infrastructure as code script and say, can we get this application running in a standalone project that we've kind of isolated out from things? We've got a DR project that we build, recreate everything from the network to the cluster, and then we deploy the applications. So how do we deploy the app? Well, the app, basically, anything we have our container, the containers get deployed in what's known as pods. So within the Kubernetes cluster is made up of these virtual machines, okay? And in there they have the Kubernetes code on how they should go about working. So this command, gcloud container create cluster, clusters create K1, that's gonna be my cluster 1. That has deployed the nodes, the workers that are gonna run our containers for us. We've got the master there that's kind of keeping and managing all that. It takes our inputs and has the sort of the rules, the declarations of what containers is supposed to run. But we don't run containers directly. We create a pod. So there's sort of a unit between a container and the Kubernetes cluster. There's a concept of a pod, and a pod is one or more containers that are going to work together. So they're our unit of deployment. Now, why do we use a pod in the middle? Because sometimes what we need to deploy isn't a single container, it might be a set of a couple containers. Like for example, sometimes we need to deploy a container, but it needs a little temporary database that just that container can use. So we might deploy another container that has a little Redis database in it. We might have that container and we might want to have it access some stateful information. So if I deploy a container running a MySQL or a Postgres database, it might need to have access to some data that actually lives even if that container is shut down, and it can reattach. And so we have all these rules, all these declarations we declare, and we tell the Kubernetes cluster, this is what we want. So this is very much part of that whole concept of that infrastructure as code, and we build up for what we're after. So when it comes time to actually run our container, we say, okay, kube control, run. I want an Nginx server, and I want you to use the image called Nginx 1.15.7. Now, I didn't tell it where to get that, so it's going to actually, it's going to reach out to Docker. It's going to reach out to the Docker hub because there's a standard image. That's sort of the repository for the generic containers out there, and it's going to pull down an Nginx server. What's an Nginx server for? We put that in front of everything these days. You have an Nginx server that can be used as a little proxy. It can be used as a cache. It can be used for a number of different things. So we want that sort of for our front-end application. And then we might have our next layer and our next layer and on back. So we just use the commands. Now you might say, well, Grant, weren't we using gcloud before? Well, gcloud told Google what to create. It told us to create the Kubernetes cluster. Kube control is a tool for managing a Kubernetes cluster. Now the Kubernetes cluster isn't Google anymore. Kubernetes is an open source orchestration platform. We just happen to be running it where? On Google. So the gcloud command created our cluster, but now the cluster's running, so kube control is how we send in commands to that cluster. So if you're running Kubernetes on premise, you don't have the Google Cloud piece, so you wouldn't do gcloud to create your cluster. Your IT team would spend a day or two building your Kubernetes cluster. We're up on Google, I'm going to write that one command to create my cluster. And once they get it all tuned up and ready to go on premise, they now have their Kubernetes cluster. And I've been sitting there for a day and a half waiting for the container because my cluster was done in about 5 minutes. That's why we like the Google side, right? But after that, we're going to run the same commands. So on-premise, you're going to deploy your container. Well, you're telling you're telling Kubernetes, kubectl, run me an Nginx server. When I have Google build it, so the gcloud command built the cluster, and now I'm just interacting with that cluster, I'm saying, please deploy this container for me. Now, these pods are units of these are the things that are scaling up and down. A simple pod has one container in it, but a pod could also have several containers that all need to work together. So that's sort of the middle piece to the Kubernetes cluster. Now, we use a deployment to basically tell it how to deploy my application. So kubectl, which asks the Kubernetes cluster, hey, what pods are you running? And it comes back and says, I've got this pod going. Now, pods initially are available only within the cluster, and they have an IP address that exists within the cluster. And even though there might be 2 or 3 or more nodes running, the pods within the cluster can start talking to each other within the cluster, but not outside the cluster. And even though that might be 3 VMs, or 3 compute engines there, it's built a network that they can all utilize because of that Google software-defined network that makes up GCP. Remember that fancy network, our private, our VPC and all that? All of that helps Google lets those cluster nodes talk to each other using one address range, and then they can talk to the public side of things through another. And we can start to expose our resources out through it. So we can have a client go via web network load balancer. So here comes a client, an end user, comes in via public IP address, goes to the network load balancer, and then the Kubernetes cluster routes that request to a pod that's been assigned to respond. Now, could there be a pod on each of those nodes? Absolutely. That's how we scale. Now, we could go with a bunch of command line utilities for this. And so this is where you'll need to start to do Kubernetes. Usually takes a couple days of training. It's not something you were just going to pick up. It's not something that, I could go fire up a Kubernetes cluster and be like, what? That's going on. And plus, it takes a little bit of time. It's one of those things, though, but there's an entire quest in Quick Labs on building a Kubernetes cluster. Actually, there's several quests where they will say, okay, this first lab, we're going to show you how to build a Kubernetes cluster. This second lab, we're going to show you how to deploy an application to a Kubernetes cluster. The third lab, we're going to show you how to deploy a Kubernetes cluster using a load balancer. We're going to deploy an application. And you're going to see that those labs build up. So if you see this in your future, and wink, wink, Kubernetes is probably in your future if you're an infrastructure person. Because remember, we don't get to manage the servers anymore. A couple of years from now, we're going to laugh at all the VMs we used to have to run because we're going to be deploying stuff. So those of you who are infrastructure people, it's time to learn something new, Kubernetes. Those application developers, you might be developing Docker containers, but guess what? Learn what it's doing underneath. Learn what Kubernetes is up to, because that's where a lot of this is headed. Everybody's got Kubernetes clusters. I can go to any of the cloud providers, they'll do this. In fact, one of the big announcements Google has with Anthos is that you can manage Google Kubernetes clusters as well as on-premise Kubernetes and potentially even Kubernetes clusters running in other clouds. Because Google is okay with cloud agnosticity. Use Google where it makes sense for you within your organization. And I know a lot of you mentioned to me at break, you work with other clouds now and you're starting in on GCP. It's not you have to pick one. It's a matter of, well, what tools and what technologies are available within the clouds for me to begin using them. So this is an area definitely worth investing some time if you're a technologist today, because it is impacting every single one of us. So here we see, well, I'm scaling my Kubernetes, my Nginx. So that was my front end for my web application. I want 3 replicas. So now there's 3 of those. Each node has one of those pods. So what happens when the load balancer comes in or an API call comes in? It gets routed to the appropriate pod. And here we just added an autoscaler. We said, hey, we want a minimum of 10 of these running. We want a maximum of 15 Nginx and use CPU at 80% to decide when do you add more. Now, as I said, Kubernetes is a declarative language. It's only when you're really experimenting or you're running individual commands. Most of the time, we're going to declare by way of a YAML file here, telling it, what do I need? I've got a deployment. I need an Nginx. It's labeled as Nginx. I want 3 replicas, and I want to use the template of the Nginx server. Down there is the container Nginx, Nginx version 1.15.7, and it should listen on port 80. That's how I would deploy. That's how I tell Kubernetes, this is what I want. And we just create for every application. As you think about Maps, Maps is going to have a whole big deployment that Google deploys out on their Kubernetes clusters. Now, their Kubernetes clusters, though, are not 2 or 3 or 4 nodes. They are probably running with, what do you think? Thousands of nodes, yes. Millions of containers are running on GCP right now in just one of the regional data centers. There are billions of containers Google has started, executed over the years. I mean, it's just the scale that they deploy these. And this is how you get to that sort of scale. Okay? Now, what about when I want to make changes? What if when I have a new container, I've got a new thing I need to release? Well, what do? I update the declaration file and I redeploy. And presto, so here we're going to 1.10 for our Nginx server. And it starts to replace the pods that are running. We can have a whole bunch of rules on how should we redeploy things. We could use kube control to see what's actually happening, so we can use it as to get an idea. We can also use consoles and dashboards and all that fun stuff to do it. We can watch our pods executions. We can get information about the deployments we're building. We can describe the deployments. We can get a lot. So when we start to build them out, we start manually, but then we think automation. In fact, everything you do in GCP, my grant mantra for the day is the first time you do something, you're probably going to do it manually with a GUI. The second time you do the same thing on GCP, think, how am I going to automate this? And the third time, what should you do? Automate it. Because if you think about how Google has to manage hundreds of thousands of servers, okay, in each of those data centers, each of those regions can have 100,000 servers in it, automation is key. If you had to run around to do things manually, you couldn't have Gmail, you couldn't have Google search, you couldn't have had Maps and all that. They couldn't have enough people working for them to do it. Automation is key with this stuff, and that's very much where Kubernetes sort of fits in that picture. So we talk about, we create the cluster, we create our declaration on what we want to run on that cluster, and then we go and deploy it. We update our applications, like in here we've just grabbed a little snippet. We're saying, hey, rolling update my application. I want you to roll. There should be 5 replicas and the minimum surge is 1. So it's going to replace one with the new version, replace one with the new version, replace and go. There's other times I might want to replace them all at the same time because I'm not backwards compatible. So there is all sorts of different strategies we can use to roll things out. So why do I deploy containers? What are 2 good reasons for deploying containers? Anybody? Scaling. Yep. What else? Portability. I can build my container and I can then go run it on a container platform on a different system. If we think dev, QA, production, so traditional deployment, I can build a container in dev, QA can test that. They could actually rebuild that because we started with the Docker file of the application. We've described what we want. They can inspect that. They can look at, they can make sure it works, and then it can roll over to production. And the same thing is moving around. So, portable. So, good answer. Simpler to migrate workloads. Building a lot of small components that make up a big application rather than big monolithic applications, and be very agile. Help with the agility of building things. Kubernetes lets me manage clusters in multiple cloud providers? Yes. Kubernetes Engine is Google's implementation of Kubernetes that runs. So we use G-Cloud to create our Kubernetes engine, but that engine part is the Google. The Kubernetes is open source. So Google just calls it GKE. So we have GCE is what we talked about this morning, Google Compute Engine. GKE is Google Kubernetes Engine. For a while we called it Google Container Engine, but then we had 2 things that were GCE, and it kind of got a little confusing. So it gives you my sort of little history back there. But now it's Google Kubernetes Engine. GCP provides a private high-speed container image storage service for doing this. Yes. You don't have to go put your containers into a public repository. Google will, within your project, has GCR, Google Container Registry. And as I said, a little bit, I'm going to teach a couple more little tools, and then I'm going to show you an application and watch it literally go from code, automatically get built, and then dropped into a container registry where I can go run it from. All right, so Google Container Registry holding that. So that's a little bit of the foundation behind Kubernetes and containers and all that sort of thing. So the next part we're going to talk about here is deploying applications in the cloud. Because if I'm not ready for Kubernetes, because Kubernetes does require training, it does require you're operating not individual servers, but you are operating a Kubernetes cluster. You're creating all those declarations and things. But what if I just want a single container, or I just want to deploy my code? Well, that on Google is done on a platform, another platform to run things. So we have Compute Engine, we have Google Container Engine, and then we have App Engine. And App Engine is used to deploy standalone type applications. Now, Snapchat, as I said, started with App Engine. And I'll almost guarantee that they've gotten better and better at container orchestration and are now running more on Kubernetes because they get more control over things. But if I wanted a simple little web application, I deploy that on App Engine. Okay? It's platform as a service for building scalable applications. We make deployment, maintenance, and scalability. All you have to worry about is the code. Great for building simple little applications or even complex applications. Mainly web applications because it's internet facing, but you don't worry about IP addresses or any of that sort of stuff. You just worry about writing code. So the earliest form of Google Cloud Platform is over 10 years old, and it was App Engine Standard. It was where, hey, if you build your application to Google's specification for App Engine, which said you could build on Python, Java, PHP, or Go, and bring your code to Google, they will host that application for you. Okay, and this is over 10 years old. The problem is, it's like a sandbox. We had to follow their sort of rules. Specific languages. I couldn't write to local file system. I couldn't have a bunch of stuff installed. Because I want you to envision App Engine is thousands of servers out there waiting for web requests. And what we do is we have to deploy it. Now, I'm going to deploy something to App Engine Standard here for us really quick, just to show you what it actually does. So let's switch over to my machine here. And I'm going to show you what I got. Okay, so I've got a simple little, oh, where is it? Sorry. Where's my simple little app engine? Yeah, so here's a little simple little app engine. This is just some simple Python. So a lot of this is just boilerplate. In here, I'm using a Flask application, and I'm going to define a hello. Okay, that's my code. Small little piece of code. Should I have to go run a compute engine, build a web server, and run it on that? Probably not. Should I have to take that and go run that on a Kubernetes cluster? Probably overkill. Instead, I would like to take my main.py here, my YAML file that says this needs the Python 3.7, and my requirements, this says I need Flask. And I would like to deploy that to Google. Now, every Google project out there gets to use App Engine. So I'm going to jump over here to my home Philly. I'm going to click here because I just want it focused on the project called Philly here. And I'm going to go into that directory. So I'm going to go into, this is my GCP folder. I'm going to go into app. And so there's those three files. So I'm going to say gcloud app deploy. I'm going to say enter. And go to say, okay, it doesn't look like you've used App Engine on this project. Where would you like us to deploy this to? So I'm going to say, okay, Google, I'd like you to deploy that to US Central Region. They say, okay, we're going to create you an App Engine for your project. And it's going to need a little bit of time here. But what it's basically doing is taking that content there. Oh, got to do one more thing. They said, all right, we're going to deploy this. The source is in your home directory, App Engine. You're going to put it into the GCP Philly project. It's going to be your default, and we're going to put it on this URL for you. I'm going to grab that URL while I can. That way I don't even have to type it. Okay. And so we're going to say, yep, that's what I want deployed. So what I like to think the visual of this right now is Google is taking that directory and they're dropping it into a bucket. And now when I go, there's probably a container in the middle there. But what happens is now when I go to that URL, my project name, gcpphilly.appspot.com, Google is going to route that to one of these thousands of web servers they have running appspot.com. And when that gets assigned, so let's say that's you right here, you're the web server that gets assigned, you're literally going to go reach in a bucket and pull out those files, and you're going to present them as a web application. And it'll be done here in just a minute. When I want to deploy a new version, what do? I replace that, so I redeploy. And what does Google do? They replace what's in there, and the next time a request comes, they go and handle it. So it doesn't take long to deploy App Engine. How many of you could write a simple little web code? Python, Java, PHP, or Go? Yeah, you're ready to do App Engine. Okay, you just need a Google project. There's a number of quick labs that have you do this. Now, this is a very simple one, but next step would be, well, maybe I want to use a database, but I don't want to use a SQL database because I got to have that SQL database defined for its best and worst case scenario. But I also don't want to have to build a cluster or anything. I just want it to run, and I want to pay for basically what it does. And I think it's ready. Let's see. I'm going to go up to my web browser here. Now I'm going to paste in gcpphilly.appspot.com. Hello, Philadelphia OnBoard. We have now deployed an application. I didn't have to worry about the web server. Now, what about custom URLs and all that? That's just follow a little couple lines of things you need to do as far as putting domain names behind that. But presto, we have deployed an application to here. Now, about 3 years ago, I was putting together a little demo. I was actually teaching a class on Internet of Things, and I thought it would be really cool to make an Internet of Things-like concept. So I have a project out there called IoT Demo, but I wasn't paying attention, and there was already a project called IoT Demo, and you can't have two projects with the same name, so Google dropped a number on it. So they put .1315 on there. So this was an idea. I built a quick little application, actually using one of the demos from the predecessor to Quick Labs, and I went in there and I said, all right, this would be really cool. Everybody in my class could be an IoT sensor for detecting earthquakes. And then I actually had a thought about this. I'm like, wait, this would actually be really cool because you could have earthquake sensors around the globe that every time they see, so I could go to a bunch of universities and and government and non-government entities and things like that and say, hey, if you see an earthquake more than 1.0, please post your data to this page. And they do that all the time when they see things. They just need to post the data. It's not really in production though, but I think it should be. Now, what does it do? It collects the data. So I've had some fun with it over the years. This is deployed on App Engine. Now, what's the sensor type? I played with the list. We added things over the years. Let's see. Let's worry about a zombie apocalypse. It's medium. It's Thursday. Almost the end of the week. Okay, so I'm going to post that. But let's imagine if this was actually in production scale. If I had to have regular servers and I had 10,000 sensors around the globe and the big earthquake hits, what has to happen? They're all going to start reporting in. So I could go from nothing to 10,000 posts a second. No time to warm up, no time to scale things up, clusters, no time to scale up autoscalers. Those usually take seconds or 30 seconds or a minute or so, not instantaneous. But this would. Because Google's already got thousands of servers running AppSpot. And literally, a request gets routed to you, you reach in the bucket, pull out the code, and present the code. I don't know what size SQL database I need behind the scenes, so I better not use a fixed size database. I should use a database that is pay per read and pay per write. So I'm going to go ahead and submit this. Feel free to submit one too if you visit my site. So there we go. 1010, grants Philly sensor, zombie apocalypse. I was in Knoxville earlier in the week and we had a tsunami warning. Knoxville, tsunami warning. Nothing? Okay. All right. So now let me take a look at my project. So this is just another project I have running. It's actually a standalone project that I built under my Gmail account. And this is deployed on App Engine. Now, App Engine, if I go take a look, I'm on the 8th version of my application, and we had some sudden usage on it. And Google's given, it shows I've used 0.04 instance hours for the front end for App Engine. I've had some data store writes. I've had 2 writes, and writes are $1.80 per million writes. I've had 70 million reads. So 7 of you opened the page, or 6 of you opened the page, and then I posted mine, because that reads back. My page shows you the first 10 rows coming off of the application. Just quick little fun thing to put together. And back here, you basically pay for how much time Google spends serving it. What happens if nobody touches this page for 3 weeks? No charge. What if I don't do the database operations? Nobody clicks submit. There's no write operations to the database. In fact, Google, if you go up to GCP, you go up to Google Cloud Platform, and you go ahead and do GCP free trial using your Gmail account, it's the free tier, free trial, Google will get you started with that on the free tier, and they will give you 28 hours a day of App Engine to deploy your app. They'll give you 1 gig of Firestore Data Store database rights, including a 1 gig database with 50,000 reads, 20,000 writes, and 20,000 deletes a day. They'll give you a F1 micro instance. This is in addition to a $300 credit that they'll give you to start to play with GCP. But this is always free. This is idea to get you started using GCP, to deploy a quick little App Engine. So even that one I just deployed on Philly is never going to cost me anything, because I'm not using that much compute. But this is one of these ideas. We get 5 gigs of cloud storage. We get a whole bunch of free usage around Google. We've still got a few more things to come across. The Kubernetes clusters. You don't pay for the management of Kubernetes clusters, you just pay for the computing time it uses. And so this is what leveraging GCP is all about. And getting started with GCP, money shouldn't be the problem to get started. I always like to say, take that Saturday night idea. If it still sounds good Sunday morning, build it, deploy it. Minimum viable product, MVP. Put it onto Google. You don't need compute, you don't need to build the cluster, you can just start writing code if that's where you're at. Now, let's flip back to my slides here for a minute, and let's now explain what Google App Engine Flex does. So that was standard. Standard is just give Google your code. That's why I said this is the longest running product on GCP. Okay? Now, the next part, if we go back to the slide deck here, the next part is what we call App Engine Flex. Now, App Engine Flex, because App Engine Standard, that's a Java, PHP, Python, and Go. It's not going to run every piece of code you ever do, because you're limited, because Google literally is running you on different servers as your page goes. They reach in a bucket, grab your code, and present it. App Engine Flex, though, this is just some more kind of info on App Engine Standard. App Engine Flex is a container instead of code. So anything you can containerize that will run in a Linux container can be deployed on App Engine Flex. Now, App Engine Flex happens to have a small compute running all the time. So it doesn't scale down to nothing like App Engine Standard, because they've always got to have at least 1 instance of your container running. But if you need more, they'll fire up more. But guess what? They're even working on that. There's a new platform that's in beta right now called Cloud Run. And Cloud Run is literally fire up the container when you first need it. Keep it running as long as calls are being made, and when it stops, drop it down. So it literally can scale to 0 and abstracts the whole servers behind the scenes. But right now, if maybe I just finished some online training on how to build a container. I've created myself a little containerized app. It's like, woohoo, I built a containerized app. What do I do with it now? I load it up on App Engine Flex, and I can deploy that. And then, presto, it's now running. And it can be since it's in a container, it can be anything I put inside that container. So my code, if I have some custom libraries and other things like that to run. So that's where we do App Engine Flex. So to contrast the two, one is App Engine Standard, which really is about millisecond startup, because the servers are already running and Google just has to run your code. App Engine Flex has a little bit more. There's always one running with Flex, but when you initially deploy, it's got to start that instance up, and then your application's ready to respond. So it's great if you're new to containers and you're not quite ready to go to orchestration, because you just have one container or so to run. So, but they're both platforms literally that are serverless, or managed service or serverless from your point of view. You don't have to worry about the stuff behind the scenes. So when do I use Kubernetes? Complex container orchestration, large scale deployments, complex, lots of containers that all need to work together. When do I use App Engine Flex? When I have a single type container, very simple container structure, and I really just need to scale up and down. And I use App Engine Standard when I want to deploy code. Now, the other parts on GCP that things start to happen in, one is cloud endpoints and also Apigee. Now, these are both basically for hosting APIs in the cloud. So you've got a Kubernetes cluster, you've got App Engine, you've got VMs behind the scenes, and you would like to expose those via RESTful-like APIs. Now, so there's sort of two directions on Google you can head. One is known as cloud endpoints. And what they do is they let me, so as consumers, they could actually go through and talk to my API, and then that's their interface, and I've got all my complex stuff behind the scenes. And the user just interfaces with the API, or their web page interfaces with the API. So a simple example of this is, let's say back here, I've got a feed and I'm gonna try to offer currency as a service. So if you tell me, hey, what's the dollar to pound right now? Well, you would call my API to do that. And back behind the scenes, I've got the feed coming in from Bloomberg and Reuters, and maybe I'm averaging those together. I'm coming up with, hey, this is what it should be, or this is, these would be good rates. Here's a good spread on that and all that. My consumer doesn't need to know the details. They just want to say, what's the current rate on dollar to pound? What's the current rate on dollar to rupee? What's the current rate on dollar to New Zealand dollar? That sort of thing. So I expose that as an API. So endpoints could do that for me quite easily. And I could go and create that. Google handles everything basically from that API layer out. Now, gives me RESTful interface. I can control access. I can work with Google API keys and web tokens and all that sort of stuff. I can even generate client libraries that expose my APIs to people. And so the platforms, I can handle App Engine Flex, Kubernetes, containers. And then on the client side, there can be Android, iOS, anything that can call my RESTful services. So really, that clients could be anything. Now, a couple of years ago, Google acquired a company called Apigee. And Apigee, just like all the big companies, everybody's out there acquiring when they see something really cool that does really neat things. What do? They buy it. So Google acquired a company called Apigee. And Apigee also does endpoints, but this starts to come in, and it basically gives you a way to secure and monetize APIs. Okay, so it kind of adds some more capabilities. Now, depending on how you need to deploy the APIs, we'll decide, are you going to leverage Apigee or are you going to leverage Edge? And this is one of the things you'd really need to work, sit down with some Google team or a Google partner who kind of specializes in this space to find out what's your exact use case between the two. So in the large financial institutions, I see a lot of Apigee being deployed. We don't, as trainers, Google authorized trainers here, we don't tend to do Apigee. Google's got like a special team of that, because it's really a specialty developer, kind of area there. But you'll see more and more about this stuff as far as endpoints. But the idea is to make APIs hosted by Google and to use the same sort of interfaces they use for everything. So that's what's going on with application deployment on Google, whether it be the application directly or whether with an API in front. All right, so 3 advantages of App Engine Flex over Standard. Standard is code. App Engine Flex is container, yeah. So we get a container. We can get into that container, okay? Because when you deploy containers, because you have control, you can actually get in and do some troubleshooting, because you can connect into containers when they're running. They can do disk writes because you're actually running on a node that you control. It's not on a generic platform out there. And then some integration running, because you can really run any code base. So you're not limited to just what App Engine Standard does, which was Python, PHP, Go, and Java. Here, anything you can put in a container can be deployed on App Engine Flex. All right, endpoints and Apigee. Apigee, endpoints is really about creating and maintaining your APIs. So we tend to think internal on a lot of those. Apigee really adds security and monetization of APIs in there. So if I build a currency that I wanted to use inside an internal application so my users could query for my internal app and then pass back at the value, great. But if I needed to have instead I needed to monetize, I wanted to offer it as a service, Apogee would tend to send me that way. Although we will see Apogee be used internal quite a bit as well. Yep, rewards, other things, yep, exactly. All right, so the last little piece is one, how do I do a deployment in the cloud? How do I actually deploy an application? So Google has source repositories. That's where code can live. Okay, it's a fully featured Git repository. So instead of going out to a public Git repo, which is not good for enterprise software, we're going to an internal Git repository, which might be a little tricky when I'm starting to develop up in the cloud to come back to that on-premise Git. We can actually, within our project, have a small little Git repo hosted within Google Cloud Platform. Every project gets one. We can go ahead and use that. We can check code in and out using the same Git tools we're used to and all that. And it'll even integrate in with Google Stack Driver, which is their monitoring and logging platform and things. There's Cloud Functions, which are single-purpose functions that do one thing. Node, Python, or Go, we can literally deploy a function, not a whole application in the cloud, a single function. So say, when a user puts a file into a bucket, please execute this. When a message is sent through my infrastructure, please execute this function. Often that function runs for milliseconds. And guess what we pay for? Only the time it uses for execution. Okay, so Cloud Functions are basically used for small little applications or small little functions we need to deploy. And there's a lot of this stuff going on out there because I don't want to have to deploy whole servers or have servers sitting there idle waiting for requests. I want to fire them off and go. Now, to give you an idea on that free tier usage, you get 2 million invocations of Cloud Functions a month. 400,000 gigahertz seconds of computing time, something like 200,000 gigahertz or 200,000 gigabyte seconds of RAM to play with these to get these to go. Because this is where, if we think, we had VMs and then we had Kubernetes and stuff. This is kind of out here is like a really crazy, a really new next generation. Is I could now build a web application that was almost self-contained on the client, or I build a mobile application that's running on a mobile device, and it only calls the function when it needs something. So there's no server, it's constant communication. It just fires the function off and then returns the results. So Cloud Functions are one of those areas on GCP that has a lot. Now, we deploy a lot of that out onto GCP. So Cloud Functions and the source code repositories can work well. Our Docker files can be in cloud repositories and built. When we want to do whole automation, like whole Kubernetes cluster creation, whole VM, network architecture, firewall rules, IAM policies, all that, we turn to a deployment platform like Deployment Manager, which is Google's internal deployment tool for doing infrastructure as code, or we turn to Terraform. Google works both well with Deployment Manager, their internal tool, but also with Terraform, which is from HashiCorp, which is a cloud-agnostic infrastructure as code. Anybody using Terraform? You'll find Terraform templates for all of GCP out there. So if you're already using it for working with other clouds, you might find, hey, I can start using it with GCP. You don't have to relearn new tools. And when Google releases new features, they're actually releasing most of those new features both into Deployment Manager as well as Terraform about the same time. At the Google Next conference, which is in San Francisco every April, Terraform had a humongous booth. I mean, they are, Google and Terraform are working really well for infrastructure automation together. And then Stack Drivers are platform for doing our automation, for doing our monitoring, debugging, logging. Now, the main first ones you'll work with is things like logging. Who started that VM? Who created that VM? When did it boot up? When did it shut down? Monitoring for saying, this web application is down. Please watch this website, alert me when things are down. When I get more than a certain amount of errors, or when disk space is getting full, or things like that, a lot of that will come out through monitoring. So monitoring and logging are the big beginner type things that you will use everywhere. If you are working with App Engine, well, App Engine, you're going to start getting into the debugging and the error reporting because, well, there is no other way to see what's going on in something like App Engine. It's all running up on Google. So this is where it's putting out all that information. Same thing with tracing and profiling. But everything to do with logging and everything on Google is in Stack Driver. So it's got monitoring, logging, tracing, error reporting, debugging. There are APIs, so you can begin to implement these into your applications as well. And you'll see when you're in the Google Cloud Platform Console, you'll see a whole branch that talks about Stackdriver. And that's what it is. It's Google's platform for everything to do with basically monitoring, logging, etc.